9.4, example 1. In this example, we're going to look at proving that a series will converge using one of our tests. So we're going to prove that the series n equals 0 to infinity of x to the 2n divided by n factorial squared converges for all x. So the first thing we're going to do is we're going to apply our direct comparison test, but before we can do that, we have to decide if this has negative terms or not. So when we look at this, we know that n is always going to be positive, and x to the 2n, well, it's basically x squared or x to like the 4th or the 6th, so this always has positive terms, which means there's no negative terms, okay? So the next step is to compare it to another function. So step 2 is to compare x to the 2n divided by n factorial squared to another sequence that we know. And what's going to come really in handy is that chart that we have that describes the different series. So what we want to do now is go ahead and look at this little chart a little more closely. So if we zoom in, we can already see that this one's not it, this one's not it. Hey, this one's pretty close. So what we're going to want to do is compare our function to this. So I go, okay, so this is my function, x to the 2n divided by n factorial squared, which is strictly less than or equal to x to the 2n divided by n factorial. And the reason I know that this is bigger is because if I look at the denominators, my denominator is smaller, which makes the entire number bigger. And I can write this as x squared to the n over n factorial. So one thing we do want to recall is that, and that's again from the formula sheet, that x to the n over n factorial is equal to e to the x. So x squared to the n divided by n factorial is e to the x squared. And we know that this is going to converge for all x, therefore this converges for all x. So what we've done is we've shown something larger, which is this piece, converges, so the thing smaller has to converge. So now we just have to write that out using our sentence. So since the summation from n equals 0 to infinity of x to the 2n divided by n factorial squared is less than or equal to the summation from 0 to infinity of x to the 2n divided by n factorial, and the summation of x to the 2n divided by n factorial is equal to e to the x squared, which we know converges for all x, then by the direct comparison test, we've shown that the summation from 0 to infinity of x to the 2n divided by n factorial squared converges. So the way again this works is we put our conditions. Since this is true and this is true, which converges, then we write our theorem. By the direct comparison test, this piece must be true. So if, then true. Alright, so on your own, I want you to try to prove that the summation from 0 to infinity, or that you can say the series from 0 to infinity, x to the 3n divided by 3n factorial, converges for all x. And you do the same way. Go ahead and use the direct comparison test. Alright, so let's give it a try. So the first thing I need to do is show that it's non-negative. Well, if I look at x to the 3n over 3n factorial, I know that these numbers are going to be positive. So the question is this going to be positive? Well, if I plug in 1, I get x cubed. If I plug in 2, I get x to the 6th. So every other one's going to be positive. If we can show this will be negative, then this won't work. So let's see what the function that represents this is, and then we'll talk about if it's going to be negative or positive. So the first thing I'm going to do is I'm going to compare sigma n equals 0 to infinity, x to the 3n over 3n factorial is less than or equal to sigma n equals 0 to infinity, x to the 3n divided by n factorial. And we can all agree that n factorial is less than 3n factorial, which makes the whole number larger because the denominator is smaller. Well, using the same technique as before, we know that this piece is going to equal x cubed. Now this is always positive. And because that's always positive, we're good. And we're pretty much done. That's really all there is to it. So we write our little dots. and we're going to write our sentence. So since the summation from 0 to infinity of x to the 3n divided by 3n factorial is less than or equal to the series of x to the 3n divided by n factorial, which is equal to ex cubed, which will converge for all x, then by the direct comparison test, our original series will converge.